Okay guys, let's talk about certain questions on quadratic equations. First question says if tan A and tan B are the roots of this quadratic equation, which is x square minus px plus q equals 0, then what is the value of sine square A plus B? Now see, the quadratic equation given is x square minus px plus q equals 0. Alpha is a root, beta is a root. Alpha is nothing but tan A, beta is nothing but tan B. You know that sum of roots is minus of coefficient of x upon coefficient of x square. So it will become p upon, minus of minus p is p upon 1, which is p. So you are getting that tan A plus tan B is p, and product of the roots is constant term upon coefficient of x square. So it is q upon 1, which is q. So you are getting tan A into tan B is q. Now you need to talk about sine square A plus B. First of all, understand that tan of A plus B is tan A plus tan B upon 1 minus tan A tan B. Now this is involving the sum and the product of tan A and tan B. I have already the values of those. So let's plug in the values. Tan A plus tan B upon 1 minus. This is tan A plus tan B. Okay, so tan A plus tan B itself is completely just p. So tan A plus tan B upon 1 minus tan A tan B. What will be sine square A plus B? Now see, somehow I need to use tan. If tan of A plus B is this implies tan square A plus B will be p square upon 1 minus q whole square. I can write sine square in terms of tan. How? Sine square A plus B upon cos square A plus B. This is tan square A plus B. To nullify, this is multiplied by cos square A plus B. This is tan square A plus B. This complete expression is tan square A plus B. And tan square A plus B's value you know. So you basically are getting tan square A plus B multiplied by cos square or divided by 1 by cos square, which can be written as tan square A plus B upon sec square A plus B. Now tan square A plus B is p square upon 1 minus q whole square. What is sec square? 1 plus tan square x is sec square x. So sec square A plus B is 1 plus tan square A plus B, which is p square upon 1 minus q whole square. So your answer eventually comes out to be what? That sine square A plus B is p square upon p square plus 1 minus q whole square. So sine square A plus B is p square upon p square plus 1 minus q whole square. Talking about the next question, p and q are distinct primes. Okay, p and q are distinct primes and this has distinct positive integral roots. Then what is p plus q? So no information about the roots is given to you. You are just given that this p and this q, they are nothing but primes. I am saying let alpha and beta be two roots of x square minus px plus q equals 0. Sum of the roots is p, product of the roots is q. If alpha into beta is q and I know q is a prime, by this relationship I can say that alpha divides q and beta also divides q. But because q is prime, only two numbers can divide q, 1 and q, right? Only 1 and q can be the factors of q if q is prime. So this implies alpha is 1 and beta is q. If alpha is 1 and beta is q, this is going to become what? 1 plus q is p, or p minus q is 1. Now if P and Q are primes and their difference is 1, they are integers, I only have one option, that P will be 3 and Q will be 2. That's it. P has to be 3 and Q has to be 2 only, then P minus Q will be 1 when P and Q are given to be prime. Right? If P is 3, Q is 2, very easily P plus Q is equal to 5. Okay? If X is real and K is this, then K is actually lying in which range? Let's talk about this question now. Here if you cross multiply, what do you get? Kx square plus Kx plus K equals x square minus x plus 1. So you get Kx square minus x square plus Kx plus x plus K minus 1 is 0. So you get x square common, K minus 1, yes, this is x square, Kx square plus Kx plus Kx square minus x plus 1. So Kx square minus x square, Kx plus x plus K minus 1. So you get x square K minus 1 plus x K plus 1 plus K minus 1. If it is saying that x is real, now this is a quadratic equation in x, this is quadratic in x. If I know this is quadratic in x, its roots are nothing but values of x for which this equation holds true. X is given to be real, that means the discriminant of this quadratic equation is non-negative. It cannot be negative because otherwise you're going to get imaginary roots. So in here the discriminant is non-negative, that means b square minus 4ac is non-negative, this is b. So k plus 1 whole square minus 4 into k minus 1 into k minus 1, this is greater than or equal to 0. This becomes k square plus 1 plus 2k minus 4k square. This is plus 1, so minus 4, minus 2k, so plus 8k. So you get k square minus 4k square, which is k square minus 4k square gives you minus 3k square. Then you have plus 2k plus 8k, that is plus 10k, and then you have plus 1 minus 4, which is minus 3. Okay? This I can write as what? 3k square minus 10k plus 3 is less than or equal to 0. I can write it like this because minus sign I took out common and then I got rid of that minus sign. So therefore the inequality basically changed. This can be written as 3k square minus 9k minus k plus 3 is 0, because minus 9 minus 1 is minus 10 and minus 9 into minus 1 is 9. So 3k comes out common, you're left with k minus 3 minus 1 k minus 3. This is less than or equal to 0. So you basically get k minus 3, 3k minus 1 is less than or equal to 0. And if I talk about, this is k equals 1 by 3 and this is k equals 3. What do you get in here is, when you take values less than 1 by 3, this is negative, so the product comes out to be positive. Here, this is positive, this is negative, so the product is negative. Here, both are positive, so the product is positive. I want those values of k for which it is less than 0 or equal to 0. So at 1 by 3 and at 3 it will be equal to 0, and in this particular range it will be less than 0. So k should belong to 1 by 3 to 3. K should belong to 1 by 3 to 3 closed interval. K should be greater than or equal to 1 by 3 and less than or equal to 3. Moving to the next question, we have the concept of harmonic mean popping up in this quadratic equation. So you know how mingled up situations can be in the questions. Harmonic mean of the roots of this quadratic equation is 4. Now if I am saying alpha and beta be the roots of the quadratic equation given by 1. In that situation, harmonic mean of alpha and beta is given to be 4. If you don't know the formula for harmonic mean, you will not be able to proceed after this step. So you actually are given that twice of alpha beta upon alpha plus beta is 4. This is where the harmonic mean concept has come up into picture. That twice of alpha beta upon alpha plus beta is 4. That means alpha beta is twice of alpha plus beta, because 2 and 4 get cancelled out. So 2 into 1 is 2, 2 into 2 is 4. You are left with alpha into beta equals twice of alpha plus beta. Alpha into beta is product of the roots, which is constant term. This is the constant term upon coefficient of x square. So it is 8 plus 2 root 5 upon 5 plus root 2. This is twice of alpha plus beta, which is sum of the roots, which is negative of coefficient of x, that means b, upon coefficient of x squared, which is 5 plus root 2. So very easily this has got cancelled. B is coming out to be what? What is the value of b that you're getting? B is coming out to be 8 plus 2 root 5 upon 2. Very simple. 2 comes out common. 4 plus root 5 upon 2. B is nothing but 4 plus root 5. So answer is option number D. Clear? Moving to the next one, we have the number of integral roots of this equation is what? Let's see. See, working out with x to the power 4 is a tedious task. So we basically focus on one thing, that whenever there are variables, they are actually coming in the exact same fashion. Here also x to the power 4, here also x to the power 4. So what I do is I just take x to the power 4 to be equal to y for simplification. And then I'm left with y plus root over y plus 20 is 22. Fine. Now things are pretty simple. I'm just going to let this be here and send this y that side, and the purpose should be very, very, very crystal clear that I need to square both sides so that I can get rid of the square root sign. So when I square both sides, what do I get? I get y plus 20 equals 22 minus y whole square, which gives you y plus 20 equals 22 square plus y square minus 2 into 22 y. So now you are left with y square minus 44y minus y, which is minus 45y, plus 484 minus 20, which is 464, equals 0. This is nothing but quadratic equation in y. Very, very easily, trust me, you can apply the quadratic formula, which is x equals, here it will be y because it is quadratic in y, minus b plus minus root over b square minus 4ac upon twice of a. That is going to give you y as 16 and 29. But y, remember, is nothing but x to the power 4. It is coming out to be 16 and 29. Is there any x for which x to the power 4 is 29? No. Therefore, y cannot be 29. All y can be is 16, which means x to the power 4 is 16, which means x is plus or minus 2, because plus 2 to the power 4 is 16, minus 2 to the power 4 is 16. So x can assume two values, plus and minus 2, among which one is given in the options, and therefore that is correct. So go through all the questions very nicely. That's it from my side. Thank you.